Okay, now that you know how to factor, I'm going to teach you how to solve a quadratic equation by factoring. So the first thing we need to do is make this look like a trinomial. So we say that we set the equation equal to 0 so that everything is on the same side. All terms are on the same side, and I get a trinomial equals 0. So the first thing I'm going to do is I'm going to subtract 42 from both sides, 42x. From both sides, 6x squared minus 42x equals negative 72. Then I'm going to add 72 to both sides. And now I've got 6x squared minus 42x plus 72 is equal to 0. Okay, so now when I'm taking a look at this, I've got everything on one side, and I've got it equal to 0. So what I want to do is I want to treat that trinomial like all the other trinomials that I've factored. And then just at the very end when I solve, I'm going to have a couple of extra steps, and I'll show you what those are. Well, pretty big numbers, 6, 42, and 72. I'd love to see if there's a greatest common factor in there that I can maybe take out to maybe shrink down some of the numbers that I'm working with. So I'm checking to see, really focused on that 6 to see if 6 or the factors of 6 can go into the other two terms without making a decimal. That way I can maybe pull out some of these factors and shrink down my numbers. Well, 6 goes into 42 6 times, and 6 go into 72? And it does go into 72. It goes in 12 times. So I'm going to factor out a 6 from all three terms, and I'm going to be left with x squared minus 7x plus 12, and all that's still equal to 0. So now I've factored out the 6, and again, I'm trying to solve. So I want to get all these terms separated from everything else. So in order to get this equal to 0, I'm just going to go ahead and divide both sides by 6 to get rid of that 6 out front, and I'm left with x squared minus 7x plus 12, and 0 divided by 6 is just 0. Now I'm going to try to factor my trinomial so I can find out what the two factors are that would multiply together to give me this trinomial on the left side. So first things first, I multiply the leading coefficient 1 and the last constant here, 12, together. 1 times 12 is 12. Now I'm looking for the factors of 12 that add up to negative 7. That tells me they're both going to be negative. So negative 12, negative 1, negative 6, negative 2, negative 4, and negative 3. And which of those adds up to negative 7? That's negative 4, negative 3. So now I'm going to break apart that middle term. X squared minus 4x plus negative 3x plus 12 equals 0. Again, I'm using the grouping technique. Some of you might have some other techniques that work as well. But ultimately, when you get your two factors, you're going to do the same process. So now I'm going to group my first two and my last two terms, pull out the greatest common factor of each. X is the greatest common factor in my first binomial, left with x minus 4. Negative 3 can be a factor of both of these, so I'm going to pull that negative 3 out, and I'm left with x minus 4 for my second binomial. Those match, so I know that I did that correctly. That's the greatest common factor, x minus 4, and I'm left with x minus 3, and all that's equal to 0. So now what I'm doing is I recognize that I've got some number x minus 4 times some number x minus 3, and that equals 0. Well, that some number x minus 4 is equal to 0, or some number x minus 3 is equal to 0, because the only way that you can multiply two numbers together and get a 0 is if one of them is 0. So I don't know which one is. They're both factors, which means they're both going to help me find my x-intercepts. There's two x-intercepts for this quadratic function, so I'm going to set both equal to 0. Set x minus 4 is equal to 0, and x minus 3 is equal to 0. So now I'm going to find out what's the value that would make x minus 3 equal to 0. So I add 4, x would be equal to 4. So that means I've got an x-intercept at 4, 0. That's one place I cross the x-axis with my parabola. Add 3 to both sides, and I get x is equal to 3. So 3, 0 would be my other x-intercept for my quadratic equation. So I could solve by setting equal to 0, like I did here, and then I can factor by grouping or whatever method you use to factor, and then I set my two factors equal to 0, and that's how I get my two individual solutions, and I turn those solutions into coordinate pairs so that I know where my x-intercepts are located. You can use this same process every single time and to find the x-intercepts without even have to graph first.